Hi students, in the last lecture we studied about the wave equation for electromagnetic waves both in free space and in medium. The electromagnetic wave, it contains electric field and also a magnetic field. They are orthogonal to each other and they will maintain this orthogonal property for the entire propagation period, even if their magnitude is changing with the time. And we also studied that these electromagnetic waves, they move with the velocity of light. Here this red line, it is indicating the electric field and this blue line indicates the magnetic field, and they are mutually perpendicular to each other. Here the electric field, it propagates in x direction and this magnetic field in y direction, and the wave propagation is in z direction. It is shown here. So in some cases the phase of these two fields, they changes depending upon the medium. The time varying fields which can exist in an unbound homogeneous medium, they are constant in a plane containing the field vectors and have wave motion perpendicular to the plane. This phenomenon is called the uniform plane wave. In other way, the phase of a wave is same for all the points in a plane surface, then it is known as a plane wave. And if its amplitude is same or it is constant, then that type of wave is known as uniform plane wave. There are some properties for a uniform plane wave. First property is that at every point in space, electric field and also the magnetic field, that is E and H, they are perpendicular to each other and to the direction of travel. And the second property is that the fields, they vary harmonically with the time at the same frequency everywhere in space. That is, these two fields which moves with the same frequency. And the third property is that each field has in same direction, magnitudes and phase at every point in any plane perpendicular to the direction of wave travel. So in a uniform plane wave, their frequency is same, magnitude and direction, all those components will be the same. That type of a wave is known as a uniform plane wave. We studied about the wave equation. So for a conducting medium, the wave equation is del square E, that is equal to mu sigma dou E divided by dou T plus mu epsilon dou square E divided by dou T square. We derived this equation in the last class. For free space, the conductivity sigma will be 0. So the equation becomes del square E is equal to mu epsilon dou square E divided by dou T square. This term will become 0. And we know the del value, del is equal to dou by dou x plus dou by dou y plus dou by dou z. And also del square is equal to dou square divided by dou x square plus dou square divided by dou y square plus dou square divided by dou z square. On substituting this in the first equation, then dou square E divided by dou x square plus dou square E divided by dou y square plus dou square E divided by dou z square is equal to mu 0 epsilon 0 dou square E divided by dou T square, since we are considering for a free space. So mu 0 and epsilon 0 is used here. Since the electric field, it varies only in x direction. We told that the electric field is varies in x direction and magnetic field is in y direction, and the propagation of the wave is in z direction. Since the electric field varies only in x direction, so the other components, that is in the components in y direction and z direction, should be equal to 0. So dou square E divided by dou x square will be equal to mu 0 epsilon 0 dou square E divided by dou t square. Since the value of these two terms, that is dou square E divided by dou y square and dou square E divided by dou z square, is equal to 0. And we know the electric field has three components in x, y and z direction. In the x direction, its component is that dou square Ex divided by dou x square, that is equal to mu 0 epsilon 0 dou square Ex divided by dou t square. And in the y direction, it is dou square Ey divided by dou x square is equal to mu 0 epsilon 0 dou square Ey divided by dou t square over dou x square. Then dou square Ez divided by dou x square is equal to mu 0 epsilon 0 dou square Ez divided by dou t square. For a free space, we know there is no charge density. So the value of rho is 0. Then del dot D is equal to 0. And we know the value of D is equal to epsilon E. So epsilon del dot T is equal to 0. When since the value of epsilon, it is not equal to 0 in this relation, here the value of epsilon is not equal to 0, then this value, that is del dot E, should be equal to 0, then only it satisfies this relation. So dou Ex divided by dou x plus dou Ey divided by dou y plus dou Ez divided by dou z should be equal to 0. Here the y and z components is equal to 0. Then dou Ex divided by dou x is equal to 0. This is the general equation, that is del dot E is equal to 0 means we are splitting this into different components, x component, y component and z component, that should be equal to 0. We already studied that the electric field is propagates only in x direction. So the other two components, y direction and z direction component, should be equal to 0. And then the equation, this equation becomes dou Ex divided by dou x is equal to 0. This equation shows that there is no variation of Ex in x direction. That is, in a uniform, here in a uniform plane, there is no variation of Ex in the direction of x. That is, it is a constant value. There is no change in its phase, magnitude, amplitude. Then we can say that the Ex is completely or absolutely a constant value. This means that the plane is a pure uniform plane, and this wave is known as a uniform plane wave. Similarly, in the case of a magnetic field, we know the equation del dot B is equal to mu del dot H. Since the value of B is equal to mu H, we can write this as del dot B is equal to mu del dot H. That should be equal to 0. The value of mu is not equal to 0. Then the value of this del dot H should be equal to 0. And we can write this del dot H as dou by dou x of hx plus dou by dou y of hy plus dou by dou z of hz is equal to 0. Since the magnetic field, it propagates only in y direction and it is completely independent of the x and z direction. So that components, that is this hx component and hz component, should be equal to 0. So from this equation we get dou hx divided by dou x, that is equal to dou hz divided by dou z is equal to 0. Then this dou hy divided by dou y is equal to 0 from this equation. That is hy should be equal to 0 in this case. Here the hy must be a constant or 0. If the value of hy is a constant, it would not be a part of uniform plane wave. That is and as a result the plane wave, it propagates in z direction. So the EM waves, we describes the EM waves with the wave equation, and the wave equation which satisfies these two conditions, then it is a uniform plane wave. That two conditions are, that is dou ex divided by dou x is equal to 0, and also dou hy by dou y is equal to 0. That are the two conditions. If a wave equation which satisfies these two conditions, then we can say that that wave is a uniform plane wave. Thank you.